Welcome, class. This is Mr. Gunn, and we're going to be discussing 1-3, and this is
Nolan.
And she's going to be helping me as we talk about how to evaluate expressions. So let's go ahead and take a look at an example of an expression. And so let's look at this, and let's evaluate this expression, 4y minus 15,
Y equals 9.
for the value y equals 9. So what we're going to do is we're going to take this value 9 and we're going to plug it in to the expression for y. And what we're going to get is we're going to get 4 times, there's no symbol between the 4 and the y. We've talked about that. That's one of those multiplication problems. So we're going to get 4 times 9 minus 15. Okay? And what we're doing now is we're taking a variable expression that we talked about the last couple days, and now we're going to find out what value this expression as a whole equals when we plug in 9. So there's the value substituted in for y. So we start out with 4 times 9, which is 36. We do 36 minus 15, and we should get an answer of
21.
All right, so if you get 21, then you have done it correctly. Now, let's take the eraser for a second. What if instead, we back up a little bit, let's change this value here. What do you think, Nolan? Pick a number. What would you like y to be equal to? Okay.
10.
Nolan doesn't want to talk. She said 10. So what happens to this expression when y is equal to 10? Well, we come back, we do the exact same thing. We take 4 times y, which in this case is 10, and then we subtract 15. Now, 4 times 10 is what, Nolan?
40.
Okay, that was quick. Good job. All right, and 40 minus 15 will give us 25. Okay, so for each different y that Nolan makes up, we can plug it into this expression, and we can evaluate it, and we get an answer. Okay? So that's what we mean when we say evaluate an expression. Okay, so let's go ahead and take a look at a new expression. Okay, let's look at an expression that has lots of variables. This is also a variable expression because while it has numbers, it has variables. And this time we have an a, b, and a c. Still a variable expression, so this time in order to evaluate it, we're going to need values for all of those letters. So what numbers do you want to use, Nolan? What do you want to use for a?
2.
Okay, 2. How about for b?
How about 5?
That sounds good. And how about for c?
10.
All right, let's take these values that Nolan gave me, and let's go ahead and evaluate them in. So 2 goes in for A. We're going to have 5 is going to go in for B, and 10 is going to go in for C. Oh, look at that. It's red, white, and blue. It's patriotic.
Yeah.
Like your grandma's birthday.
Yeah.
All right, she was born on the 4th of July. So we get 3 times 2. I'm going to use parentheses to show multiplication. Times 5 plus 10 divided by 2. So that's all those numbers that Nolan just gave us. The 2, the 5, and the 10 plugged in. So now when we evaluate this, 3 times 2 times 5, we'll start from the left to the right. Now notice that we're doing this topic after last night's order of operations. So order of operations tells me to do the parentheses first. Well, there's nothing actually in parentheses except for single numbers. Next we do exponents. I don't see any exponents there, do you?
No.
No exponents. All right. In that case, we're going to do multiplication and division from left to right. So 3 times 2 times 5 is going to get done first. 3 times 2 is 6. 6 times 5 is 30. And 10 divided by 2 is also in this step going from left to right. So 10 divided by 2 is 5. And finally, we get 30 plus 5 is 35. Now, if we change the values for A, B, and C, let's change them to a different number. So let's say that instead of 2, 5, and 10, make up 3 numbers. A is going to equal 6, B is going to equal 11, and C is going to equal 9. Do the same thing here, and we'll do 3 times 6 times 11 plus 9 divided by 2. And again, evaluating across the bottom here, 3 times 6 is 18. 18 times 11 is 198. Plus 9 divided by 2 is 4.5. And the answer, I ran out of room, but the answer is going to be 202 0.5. That's what happens when Nolan makes up the numbers. It comes out hard. All right. But no matter what A, B, and C are equal to, all you need to do is substitute in those numbers and evaluate that expression. All right, let's move on to one more example. All right, let's look at one more problem. And this one is going to be a word problem. Now, first, this is an example that's out of your book. Okay, and so let's look at the top one. They've already worked it out for you. Suppose that energy drinks come in cases of 24 bottles. The first part says to write a variable expression for the number of cases a store should order to get B bottles of energy drinks total. Okay, well let's think about that. If we wanted 24 bottles, we would need one case, right? And if we wanted 48 bottles, we'd need two cases. So let's think about mathematically what we're doing. If I want a certain number of bottles, okay, a variable expression for the number of cases a store should order to get B bottles, okay, is B divided by 24. All right, so for every case, we'll get 24 bottles. So that's what this is right here. That's the expression for how many cases as a store I need to order. Now, if I want to have 120 bottles to put on my shelves, if I take that number 120 and I put it in for B, 120 divided by 24 gives me 5, and this really should be labeled here as cases. We don't ever want to leave a number without its label. No naked numbers in my math class. Okay, so here's the answer. The store should order 5 cases to get 120 bottles. So here's a question. Okay, we're going to go ahead and suppose that the store above pays $29 for every case of energy drinks they have to buy. We're going to write a new variable expression for the cost of C cases. All right, so for every case, it's going to cost $29. So my variable expression is going to just be C times 29. Now, if I want to evaluate that for how much I'm going to spend for 5 cases, all we need to do is take this C and replace it with 5. So 5 times 29, let's actually do this by hand here. We're going to get 45, we're going to get $145. And that is how you solve that word problem. Okay, well listen guys, I'm sorry that this video went up a little bit late, but we're going to go ahead and stop now and get this online so everybody can watch it. So we're going to sign off right here. So thank you for watching. We'll practice evaluating algebraic expressions tomorrow in class. And in the meantime, this is Mr. Gunn, and this is
Nolan.
And we're saying goodbye.
Bye.